How do we ensure that when we write software that it will last as long as possible, that we won't have to keep updating it and rewriting it and revisiting it all the time? My name is Eric Normand, and these are my thoughts on functional programming. So this is a very common problem where we write some software and either we just live with the problems with it because we don't have time or a chance to go back over it and fix it, or we're constantly fixing it because there's just something messy about it. It's not right. We can't find a way to clean it up. And I'm going to say in my theory of functional programming, which divides things up between data, calculations, and actions, in that theory, it's very clear where you should start. Because as you move from, if you imagine them at the top, actions through calculations down to data, data is actually the most timeless thing. So actions, obviously, by definition, they depend on the time. They depend on when and how many times they are run. Calculations don't depend on when or how many times they're run. They're timeless, except they're opaque and they're in code. And so you may want to switch languages in the future, right? Like there's always this possibility that that code will break somehow, that you won't be able to run it anymore. But the data is much more timeless. The only risk is that the data format becomes impossible to read, or the data format becomes, or it's unclear what it's for, right? And so that's why I say we should start with the data. It is the thing that is inherently the most timeless. But also, if you start with the data and start designing the data, then you can increase the chances that it will survive for the long term. Meaning you design it, you think about the names of the parts of it, you think about how to communicate or making it clear when you're outputting this data, what things mean and what they are used for. And so that is, I think, something that I've learned over the years, that the data is the thing that is the most valuable. It is, once you're going to record some event, so that's timely. Some event happens, like a user clicks a button, or you're reading a sensor, or you're getting an image from a camera. Once you capture that, you can't go back in time and capture it again. So you want to capture it in a high fidelity format for your purposes. And so it's very important to make sure that data is kind of future-proof, that as things change, that you can still use that thing, and because that is never going to change. I mean, you can make a new piece of data from it that might be more future-proof, but that piece of data itself, it's inert, it's done. It's dead on the disk, and the way you keep it alive is by writing code that knows how to interpret it. So that data is going to last way longer than any code you write. It could be in a database, and that you're just storing all these records for everybody for all time, basically, as long as your company's around, and you hope that lasts a while. So data is where it's at. That's where we need to start. Now, how do we design the data? What is important about the data, and what do we want to capture? Well, the first thing is that you want it to be at least somewhat human readable. Doesn't mean that a human is going to read it and interpret it themselves, but it means that someone in the future can read it and write a program to interpret it. Okay, so it needs to be clear what the pieces are. You would like the names to be timeless. So one problem that we have a lot in software is when we write a name down for something, it is unclear. Well, we write the name down in code, and then we'll later on change the code to do something else with that same name. Like maybe we'll, what's a good example? Because it might not seem like a problem at the time, but often it is. So you have something like, you say, okay, first name is a string, okay, and so you just treat it like a string. And then later you say, we weren't actually strict enough. Let's say first name needs to be a non-empty string with no spaces at the beginning and end of the string. And so now you're more restrictive, and you may have first names with empty strings in them from before you started restricting that. So you've actually changed the meaning of first name in your code, and you can't read those old records. They're not readable before. And what's worse is, like, this is part of an API, clients of this API might not change for your, they might not change in lockstep with your changes. And they have data that they've been processing through this API that now it's not going to go through. So what we want is to say first name is whatever it is we first set it to. If we just say it's any string at the beginning, we can never change that. We can never change that. Now, this is for data that's going to be exposed on the outside, or an interface that's going to be exposed outside. But that encompasses quite a lot more than you might expect. So if you write a JSON to disk and make a backup, and now you need to, your computer crashes, you need to restore from backup, and you're running your importer, and the importer is different from when you wrote the stuff to the backup, and it now restricts the first name. Like, you've broken your system. You have not made a future compatible change to the meaning of first name. So what we need is names that are actually longer than first name. So we need like first name and then first name v2 and first name v3, or better yet, some kind of way of enforcing a uniqueness across systems. So you could say, hey, this is my first name, and you have your first name, and so you have like a namespace or something where it's like Eric / first name, and you have, Mary / first name. And so we know that they might not be compatible with each other, but we can always identify which one we mean later. And of course, none of them can change, and that's the important thing. And we have this with some committees will come up with data formats. Like, I know I used to work in geospatial organization, and they had a lot of data formats because they wanted to exchange geographic information, like where is this city located, what's the latitude and longitude, and so they had very, very well defined formats. We also have stuff like URLs have a standard for what's allowed in a URL and how to parse it. Same with email addresses. So we have these standards sometimes, but then sometimes we don't have standards. I don't know of a standard for like person name, that is universal and widely used. But if we had one, maybe there is one. I don't know all of them. But if we have one, we should use those because they have a standards body that doesn't, if they're doing their job, they're not making these incompatible changes. That they make it so that everyone can rest assured that if you write to this format, you'll be able to read it in later, and other people will be able to read your data, and you can read other people's data. That's what we want to ensure. All right, so design your data first and make it timeless. And timeless in that sense of like, you could read this database in 20 years, in 100 years. Make sure that it's clear what it means and that it's human understandable. Like the names make sense, that you're not changing the meaning of those names over time. And that is how we need to approach it. Now, the thing is, I hinted before in another episode, in the one on variance, I hinted that what tends to happen, even if you do start designing your data first, what tends to happen is we get these like super complex, deeply nested data structures. Closure programmers are notorious for being guilty at this. They will just throw data into maps and then deeply nest those maps, and then they complain about forgetting what keys they have and what data things are expecting, and how to get out what path things are at in deeply nested in their data structures. And so in the next episode I want to talk about that problem and its solution. All right, so I love getting questions. I'm Eric Normand on Twitter, and you can also reach me at eric@lispcast.com. So please send them over. Please subscribe and tell your friends about this podcast, if you like it, of course. All right, see you later.